Good morning, good afternoon, everyone. We are delighted to have a presentation today provided by Professor Ariel Dinar. As usual, what we're going to do is there will be an introduction of the speaker. After that introduction, the floor will be given to Prof. Dinar, and then afterwards there will be our Q&A sessions, and from there we will be closing the presentation. Then thank you for being available. We really appreciate your availability, but we're also looking forward to be truly engaging with you and throughout this great presentation. Today we have a great speaker. Ariel is well known in the field. He is a distinguished professor of environmental economics and policy, Emeritus at the School of Public Policy, and a professor of the Graduate Division at the University of California, Riverside, United States. His work has focused on various aspects of economic and strategic behavior associated with management of natural resources and the environment. Professor Dinar received his PhD from the Hebrew University of Jerusalem. Since then, he spent 15 years in the World Bank working on water and climate change economics and policy. In 2008, Professor Dinar assumed a professorship at the University of California, Riverside. He founded the Water Science and Policy Center, which he directed until 2014. He is an international fellow of the Center for Agricultural Economic Research of the Hebrew University of Jerusalem, Israel, since November 2010. He is also a Fulbright Senior Specialist since 2003 and was named a 2015 Fellow of the Agricultural and Applied Economics Association. Professor Dinar has authored and co-authored more than 220 publications in peer-reviewed journals, policy outlets, and book chapters. He co-authored and edited 29 books and textbooks, and he founded 2 technical journals. One is the Strategic Behavior and the Environment, and the second one is Water Economics and Policy. For the latter, he serves at present as the chief editor. He founded also and serves as the editor-in-chief of the book series Global Issues in Water Policy. And therefore, today we are very happy to listen to Professor Dinar, and I'm very much sure that we have a lot to learn from his talk. The floor is yours, Professor Dinar.
Thank you very much. I hope that you can see the screen, and I am going today to talk about a general question that at least I ask myself many times. Can recycled wastewater be a good source of water and replace or amend the water scarcity in the world? I started thinking about that question many years ago, not in a global way, but in a local way, working on different aspects of use, of treatment and reuse of recycled water. And the push for this presentation came after the first presentation in this seminar series about the wastewater around the world by Professor Mansour Kadir And he gave me the last push to prepare a question and to try to answer it in a short seminar by using several examples from mainly my work and work of others. I will start by, again, to Professor Mansour Kadir, and I'm going to use some of the ideas from his presentation. Let me just go and... So the question is it is true that wastewater amount is increasing in a very significant way over time? And the question, which is the question of that presentation, is whether or not this is a sufficient condition to have wastewater close the gap between demand and supply. So this is the motivation for the presentation. And it is indeed, everyone knows, even kids in elementary school, that water scarcity has worsened in many parts of the world due to several causes. First of all, population growth. More people, they need more food, they need more water for irrigation, they need more water for their own in-house uses. Then comes another factor that affects the water scarcity, and this is climate change, that in many parts of the world, it is manifested through decline and uncertainty of water supply and higher temperatures, which increase the needs of plants for irrigation. Urbanization. So more people move to the urban centers, more water is used by the households. Then economic growth. I mean, we see almost in every country around the world the increase in the economic performance, which means more activities that require water. And then we also see increase in the lifestyle of people. That means they use more water because they have more showers, they have lawns that they need to irrigate, they have pools, and all of that in many parts of the world. But this means that we have a trend of increase in water scarcity, but on the other hand, almost all the same reasons that were counted earlier are supporting the increase in wastewater, both locally and globally. And if this is the case, if this is so nice, so why should we be concerned? So the question that I will try with you to address is, are more available wastewater resources the only condition for relaxation of the water scarcity? And globally, and this is indeed a sufficient condition to have more wastewater available for use, but there are some additional concerns that I will try to prove or to demonstrate with studies. And these are the additional considerations that are necessary. Our treatment system needs to be sustainable to climate change. Climate change does not affect only the use of the water by the users, but also the ability of the water treatment facilities, WWF, to efficiently treat the water. A big question is the location of the treatment facility. Where will it be located? Is it located close to the source, or is it located close to the use? And the difference is reflected in the cost of transportation. The level of treatment. The level of treatment is a big decision variable, which not always is agreeable by the users. And then the ability to pay for the treated wastewater by the users. Somebody has to pay the cost. So it either comes from the polluter that needs to treat it, or polluter and users, and sometimes government subsidy is needed as well. So we need an acceptable allocation of the treated wastewater among the users. Who will get how much? We need also the distribution of the cost among the polluters and the users. How much will be paid by whom? And we need to identify compensation mechanisms so that more users or potential users can be part of the wastewater treatment facility reuse. And I call it game because this is indeed a game, as you will see soon. And then, of course, as I mentioned earlier, we need this government. Government can be either the city government or the state government or the federal government to be involved by providing regulations and support, sometimes subsidies, to help initiate the process. So we have some slides that I modified from my friend Manzoor Kadir, who showed us that over time, starting last year, where he started his assessment, the volume of treated waste or urban treated wastewater is on the rise. Start moving from 2068 million, billion cubic meters, or cubic kilometers, to 322. Very impressive increase that makes us believe that this is a good source of water to be used. So population increases, living standard rise, volume of wastewater moved from 2068 to 322 in 2050. Very good. So let's see now what are the challenges that we should take into account when we want to consider the use of that wastewater as a game changer for the scarcity around the world. So First of all, over time, wastewater composition has changed significantly. And we have now wastewater that has higher level of remainders of pharmaceutical stuff that can become very, very dangerous. It has to be addressed. Climate change, which is more sound now, is fast tracking water quality deterioration and affects the performance of wastewater treatment facilities. The location of the wastewater source and the locations of the potential use may differ. And in many cases, they are not other. The interesting, just last night I added that bullet because I was thinking about it. Urbanization. What does urbanization mean? It means that people from the villages that used to be agricultural producers, they leave agriculture and they move to the cities. And this is what we call urbanization. So if they leave the agricultural sector, then the agricultural sector that was around the city cannot anymore be a source, not a source, a destination for the water. And therefore, if the water has to be used, it has to be sent farther away for villages that use the water, or for farms that use the water that are far away from the source. So this is an important observation. And then there are disagreements. And as we will see, one or two examples that I will bring between the producers of the wastewater and the users. And this disagreement can challenge the possible use of the wastewater. What are the emerging health risks of use of wastewater for irrigation? First of all, there are emerging pollutants that are cosmetics, microplastics, and pharmaceuticals that many of the wastewater treatment procedures don't know or cannot remove. And therefore, they are absorbed by the plants that we eat. And this is a big problem. So the food chain is exposed to risks from emerging pollutants in the wastewater. This means that in order to use wastewater, sometimes we need to select certain crops that will not suck the bad stuff, but either crops that we don't eat. For example, crops that we use their yield for processing and not eating them directly. This is another constraint on the use. And we need to spend, because many of the existing wastewater treatment plants are unable to address these problems of emerging pollutants. So we need to revise the process by investing in new procedures that cost money. And is that a constraint on the use? Probably it is in certain location and in certain situations. So let's start with climate change, and I will use an example from a study that I was part of that suggests that climate change is a major has a major negative impact on wastewater treatment facilities and will have in the future. So we know from engineering studies that, and by the way, at the end of the presentation that will also become available on the website of the center, there is a list and links to all the sources that I used. So if anyone is interested, you can go to that list. So we know from the literature that climate change might have an impact on the cost of wastewater treatment. The increase in the cost can hinge on the attractiveness of this solution as a source for water. If the water becomes prohibitively expensive, people cannot or will not use it. Climate change may affect the cost associated with the direct input use. Climate change will not affect the infrastructure, but the cost of the processes of the wastewater treatment. And those costs are mainly affected by the regulatory requirements that each of the wastewater treatment facilities are facing. And these are mainly to enhance the quality of the water that is the product of that wastewater facility. So studies suggest that climate change can increase the uncertainty, the effectiveness of the human-built infrastructure by increasing the uncertainty of the air temperature, the precipitation, the wind speed, and the sea level rise. They all can affect the performance of the wastewater facility, either through affecting the process, through flooding, through demolition of the facilities from winds and storms, and create an increase to the infrastructure that is needed to cope with climate change. So infrastructure would need to be modified in order to be able to cope with climate change. And because the wastewater treatment plants are designed for a certain range of climate and flows and amount of water and quality of water that comes to the facility, any change to any of these will necessitate an adjustment in the design and in the process. And if this cannot be met, then the treatment facility may fail to deliver what it was supposed to. So this is basically our background, and a study. Oh, sorry. What happened? And a study that we conducted in China And the reason that we selected China was because this was the only country for which we could find a full data set with information about many wastewater facilities around the country that included cost and technical parameters for the facilities. So this is China, and we were able to get data from 2006 from about 176 facilities. And as you can see, these are the temperatures in China in 2006. And we can see that the northern part is cooler and the southern part is hotter. And actually the northern part is hotter. I mean, this is the northern part. The middle part is wetter or cooler, and the southern part is also hot. So we have a nice distribution of the facilities. In simulation of the climate in between 2075 to 2100 suggests that those places that were hot will become hotter. So you can see that color becomes more extreme, or temperatures are hotter, and those that were cooler will, it's very hard to see that, but they will become also more or less cool. So this is temperature-wise, and here we have the precipitation-wise. So we can see also that over time, or between 2006, where we had our data, and 2074 to 2100, we have more rain in China. So in at least in those regions where we have observations. So what did we do, and what are the findings of our study? And we had to simulate different futures. We didn't know exactly which future will take place. So we simulated different futures, and what we found is that for the 163, not 176, sorry. So first of all, the treatment technologies that they use, and which is less important for us, these are the names: the conventional activated sludge, oxidation ditch, sequencing batch reactors, anaerobic and anoxic processes. So these are the main treatment processes that were used in the different facilities in China in 2006. And there are some additional ones, they were, but less used. So because there are different treatment procedures, there are different operation and maintenance costs that represent each of them. So we estimated for each of them, we estimated the cost for each of the technology, because we had several observations. So we had information about the cost, about the amount of water that was produced. So we could estimate the cost of operation and maintenance of each of the facilities and each of the types of the facilities. So this was an important aspect. What we say, this is stage one for any study on wastewater use. And then for each climate change future scenario, we estimated the ability of each type of the wastewater facilities to withstand, or what will be the impact on their performance. We made also several assumptions on the population changes over time because the horizon is very, very long. And we made another assumption about the different policy scenarios in the case of China. So we used one policy mechanism that the Chinese government has used, and this is the discharge standards. So changes to the discharge standards in or from the wastewater treatment facilities, and this was our policy intervention. So, for example, for conventional activated sludge, the wastewater discharge standard was X ppm of BOD, for example, in 2006. And from reading the literature, we reduced it to a lower standard in 2070, for example. So for each of those techniques or technologies, we changed the standard, the discharge standards as a policy intervention. What were the findings? So the increased population will increase the demand for water, and it will create higher sewage in the cities, which means that we need to treat the water to reduce health risks and environmental damages. The increased volume can create additional cost because of all those variables that I mentioned. The wastewater collection, the treatment, the disposal, which are all capital and energy intensive processes. For most models and for the different representative concentration pathways of climate, cost of treatment are expected to increase as a result of climate change. So this is one that we need to remember when we think in terms of use of wastewater in the future as a solution to the scarcity. The uncertainty of the climate intensifies that problem, and they may have contradicting effect on the social cost and the uncertainty related to the security of those treatment facilities. So again, I highlighted in red the keywords: higher frequency of extreme climate-related events, floods, cold or hot weather. They may impair the efficiency of treatment processes. This is, again, one issue that we need to remember. Another issue, and this is an issue that is most likely the main issue in the central, or which is the central question about the agreement between users and producers of wastewater. And the question is, can disagreements among prospective users of wastewater risk the wastewater use? So what can be the disagreement? So disagreement can be about many things. About the location of the wastewater treatment facility. Should it be closer to the users, closer to the biggest user, closer to the smallest user, or closer to the producer of the wastewater? Because if it is closer to the producer, then the producer does need to pay for the conveyance costs, and all the cost of conveying the wastewater will be borne by the users. So location is a very important variable in the agreement or disagreement between the users. Now, the size of the water treatment facility. Again, water treatment facilities, like many other water projects or water facilities, has a very high economies of scale, which means bigger facilities are characterized by a lower average cost per unit of water treated. So for the producer, a bigger facility will also take into account future expansion, and it will be, again, borne by the users also. So there is a conflict between users and producers about not only location, but also the size. How big should be the wastewater facility? Shall it be exactly for the amounts to be used now, or shall it be taking into account future expansion of the city? And then what should be the level of treatment? So the level of treatment introduces now more players to be included in the debate. It's not only the city or the producer of the wastewater and the users as a group, but also among the users, there are some that their cropping patterns are such that they need a higher level of treatment. So in wastewater treatment, a very preliminary definition of the level of treatment is primary, secondary, and tertiary, where the tertiary is the most distilled water, relative, of course, and especially compared to primary. So if a farmer has crops that do not need tertiary water treatment, then they will push for lower level of treatment, which means also cheaper wastewater. Those farmers that have vegetables and that need higher level of treatment will basically need much less. And therefore, this is another point of disagreement. So we can move to two more points. One point is the observation that beyond the removal of the organic matters from the wastewater, which is the basic requirement from wastewater, there is an additional request by certain farmers, and I will mention those, for incremental treatment to remove pollutions that are not health related but are yield decreasing, like salinity. So this is another aspect of the request, and this makes treatment even more expensive. And then I sent my presentation to a colleague to give me feedback, and he told me, you should use the example of Mexico City. And in the case of Mexico City, the government wanted to fund a treatment facility that will remove content that could be considered as fertilizers. And the farmers, I don't want to take time to open the link, but you can see and read the magazine that talks about it, and farmers just protested and did not want that facility to be established, and therefore they did not have wastewater to be used. So this is just another example of how perceptions about the quality of the wastewater may affect the results. So what will be the allocation of the wastewater? How much will each farmer or each user get? And how will be the joint cost distributed both between the polluter and the users and among the users? These are the questions. So I will go very fast because I want to be able to talk about it also. So a study that was my first work on wastewater, and it was in Israel, and it was a region that has 4 big collaborative farms and 1 town that produced wastewater, and the town did not have a direct outlet to the ocean or to the sea. And the only way to get rid of the wastewater after treatment was to use them for irrigation. Again, the same questions. What should be the level of the treatment? What should be the size? What should be the location of the facility? In that work, we took the framework of a regional approach. Again, because of the economies of scale in the cost of the wastewater facility, a bigger treatment facility would mean lower cost per unit of water treated. And therefore, the more participants, the better it is for the region. So this is a regional study. And again, there were, at that time, there were very strict public health regulations. It's not what we have today. This was in 1984. So the government set standards for use of wastewater for each of the types of the crops, if they are irrigated under the canopy or if they are irrigated on the canopy. So there were economic advantages for the potential participants, and what we try to show is that each one of the participants should be interested in joining the regional project. So they had to identify what are the regional boundaries. This was an economic question that will affect the cost of the use of the water. They had to determine what should be the treatment level. In that case, it was secondary or tertiary level. What should be the allocation of the treated wastewater to the farms? Should they take into account the size of the farm, how many acres or hectares they have to irrigate, or the types of the crops, or the willingness to pay? Should they come up with an optimal cropping pattern to meet the availability of the water? And how should be the cost, not only the water, but the cost allocated among all of them? And whether or not a government subsidy is necessary, sometimes it is not. And if it is necessary, what should be the level of the government subsidy that will make that regional facility attractive to all? So both the city and the 4 agricultural settlements, they had preferences that if they are not fulfilled, they will not participate. So what are those preferences? The main one is that they wanted the bottom line of their participation to yield a situation where they are better off compared to the situation without the wastewater facility that they are part of. So what does it mean? It means that if they do not have the water, if they are not participating in that regional project, they have a certain level, a certain amount of water, fresh water, and a certain amount of land that can be irrigated. What will be the incremental benefits to each of them? So this was one of the basic requirements for participation in the regional. What should be the additional cost to be charged to leave them satisfied, which means that their benefits will still be higher compared to the situation where they are not part of that regional facility. And they were 4, but they could also create regional facilities that do not serve all 4 settlements. So a sub-regional facility is also a possibility. So if one of the collective farms decided not to be part, the other 3 could still collaborate with the town or with the city and come up with a solution. So the analysis has to take into account these options as well. And then, which I'm not going to talk too much about, is we wanted to find allocations of the joint cost and the joint benefits, or the net benefits, in such a way that each of them will be happy with joining the coalition or the regional facility. And there are several cooperative game theory that, again, I'm not going to talk about it, that provide answers to those questions. How shall we make each of the participants happy compared to the non-participation in the joint facility and any possible participation in a non-regional but sub-regional facility. So these are three game theory schemes that were used. And then, of course, we need to make sure that there is no envy between the participants, that after having the agreement, one will realize, my neighbor is making or benefits more than I from the arrangement that we reached, and therefore I am leaving the arrangement. So we need to make sure that we find an arrangement that is stable and not vulnerable to any other arrangement once the benefit and cost are allocated, that everyone is happy not only now, but also in the future. So let me just, I want to jump over that because I am running late. I'm just going to talk about the case of another wastewater treatment facility in the case of Escondido in California from 2022. And the city of Escondido is a large city, 150,000 inhabitants. It has to dispose of water to the ocean. It is a very expensive operation, especially now where the city grew up and needs to replace the conduit or the pipe. And this is a cost of close to $1 billion over 25 miles from the city to the ocean. The city is surrounded with a large avocado operation, 6,000 acres, which is about 12,000 hectares or even 15,000 hectares of avocado groves. And the avocado groves are very sensitive to salinity, very sensitive to uncertain water supply. And if the city could provide water to the avocado, additional wastewater, treated wastewater that also meets salinity regulations that needs to be addressed, the would be a win-win solution, especially if the city could subsidize the cost to the avocado growers. So this is the background. And what we found, and I will not be able to go over what we found. So this is basically what I told you. That they faced was the price of the desalinated water, so treated wastewater plus an additional desalination, because otherwise avocado will suffer. So price and the level of salinity. The more you desalinate, the more expensive the water is. And therefore, these were the two parameters that they had to negotiate. For many years, they negotiated and could not reach an agreement. And only this year, 2025, as I mentioned here, they reached an agreement. The city was able to subsidize for them the price of the water and to reach a level of treatment that they were happy with. I will stop here because I want to leave time for questions, and I am sorry that it took longer than what I was planning. If there are any questions.
Thank you very much, Professor Dinar. This was very, very insightful. I mean, we learn a lot from these interesting examples.